All right, so here we go, ladies and gentlemen. Um, this entire unit is on writing and naming formulas. Okay, so we are going to learn how to basically write chemical formulas in the appropriate manner. We are going to write ionic compounds, we are going to write covalent compounds, and we are going to do acids. Okay, this unit is probably about 2.5 weeks or so. That's how long it is. Okay, now here's the other thing. With this, okay, the only way you get better at this is to practice, to go through it and to practice and to get better and better at things. So we're going to try to give you opportunities as much as we can to do that. But also, ladies and gentlemen, a very important part in this unit will be you setting up your periodic table so that it will give you success throughout this unit. So we will talk about what that means, ladies and gentlemen, as we go through this. Okay? As we go through this, we will talk about what that means. All right? Now, here we go, ladies and gentlemen. So when you open up your new EISN, okay, Unit 3, Writing and Naming Formulas, okay, we're going to talk about the basic fundamentals of bonding. Then we are going to talk about binary ionic compounds. Binary ionic compounds are the easiest kind of compounds because they only contain two different kinds of elements. That's what it means to be binary. After that, we will get into what are called ternary ionic compounds. Ternary ionic compounds have 3 or more elements in them, and they involve polyatomic ions, ladies and gentlemen, which you can find on the back of your periodic table. Now, this is not an all-encompassing list. This is a list of most of the common polyatomic ions that we will use in class. But again, there are also some up here on the white posters at the front of the room. Okay? So I am not expecting you to memorize those. I will give them to you. I do expect you to know how to write a compound with them when it comes time. Okay? After that, we will get into what are called polyatomic prefixes. So there are ways that we will take these ternary ionic compounds, which involve polyatomics, and there are ways that we can modify them based on either a prefix in front of them or a suffix afterwards. All of this, however, ladies and gentlemen, is on your periodic table already for you. Okay? We just need to teach you the rules and how and when to use them. We will then do covalent compounds, ladies and gentlemen. A covalent compound is a compound between two nonmetals. It is an entirely different naming system. However, I think it is actually the easiest naming system because you are literally telling people what is in the compound with a prefix system. And then we will finish off with acids. Now, there are two kinds of acids. There are what are called binary acids, and there are what are called ternary acids. You have already worked with each one of these when we did the lab on chemical properties last week. You worked with hydrochloric acid, which was a binary acid, and you worked with sulfuric acid, which was a ternary acid. So now we just have to go through how to do things with them. Questions? All right, ladies and gentlemen. So let's get into the bonding fundamentals here. Okay, now, first of all, we gave you this in the last unit as well, ladies and gentlemen, the term ion. The definition is a charged particle or atom that has gained or lost electrons. Now, the reason we use a charged particle is because of these things up here, these polyatomics. They are a group of atoms that are acting as a single charged compound. They are combined. You cannot break them apart. But overall, they have a charge to them. Okay? Just like an atom can. So examples, ladies and gentlemen, and again, we've given these to you before. Now, I will admit these are incorrect. These should be written as superscripts, not just afterwards as a +1, a +2, a -2, or a -1. So we will get into showing you how to predict those and how to also write those. And we will do that today, ladies and gentlemen. Okay? Again, an ion is a charged atom. All atoms begin neutral, which means the number of protons and the number of electrons are equal. Now, again, what did we say the purpose of an electron was in the atom? To give it its reactivity. So why does one sodium combine with one chlorine when one magnesium combines with two chlorines? It all has to do with the electrons, ladies and gentlemen. It all has to do with the electrons. What, Declan?
Because like the electrons, like they see like the circle outer thing. I forgot what it's.
They were called Bohr models, and yes, you are on the right track. We will go over that. Okay. All atoms start out neutral. There are only 7 atoms that stay that way all the time. Otherwise, every atom on the periodic table will become charged. Every one of them. Okay? It is created by gaining or losing electrons, ladies and gentlemen. And if you gain electrons, you will have a negative charge. If you lose electrons, you will have a positive. We did discuss this in the last unit. But again, this is an important thing that we are going to go over. The charge on an atom is equal to the number of protons minus the number of electrons. The charge on an atom is equal to the number of protons minus the number of electrons. So if you have more electrons than protons, yes, you will have a negative charge. Absolutely nothing wrong with that, ladies and gentlemen. Nothing wrong with that. Okay? All right. So, why compounds are made? Why do atoms combine?
Because one has an extra electron and one wants an extra electron, and they just, the two circles just lock in together.
You're close. Atoms combine for one reason and one reason only. They combine to become stable. That is why they combine. They combine with other atoms to become stable. Now, the stuff you're talking about, Declan, leads us into this. Okay? But again, we can't just say the circles, do the circle thing where the atoms combine to become stable. How do we know this? Because there are 7 atoms on the periodic table that do not combine with anything because they are already stable. They are group no. The noble gases, yes. Gases, no. Okay? The noble gases are group 18 on our periodic table. Helium, neon, argon, krypton, xenon, radon, and oxygen. And those 7 elements do not combine with any other elements on the periodic table. Why? Because they are already stable. They don't need to combine with another element. Every other element on the periodic table does. So how do atoms become stable? They want to become stable. How do they become stable? They become stable by doing something called filling their valence shell. So again, when you were in physical science, or if you weren't in physical science, the valence shell is the outermost shell of electrons. How many electrons fill the outermost shell? 8. 8 electrons fill that. Okay? Now, if an atom has a full outermost shell, they are stable. The noble gases already have a full outer shell, ladies and gentlemen. They are stable already. There is no reason for them to do anything else. They are already stable. How do the other elements fill their valence shell? How do they make this happen so they can become stable? They gain, lose, or share electrons. That's it. They gain, lose, or they share electrons. Now, depending on which one you do, and by the way, gaining and losing go together. You cannot gain an electron unless some other atom is willing to lose it. And atoms that want to lose electrons cannot just go around sending them off into space to become stable. There has to be another element there that they can give them to, transfer them to, for them to lose them. So those two go together. Sharing electrons is another way they can do it. And only certain kind of atoms can share electrons. Okay? Only certain kinds of atoms can share. Only certain kinds of atoms can gain. Only certain kinds of atoms can lose. Questions? All right. When you gain electrons, you become negatively charged. When you lose electrons, you become positively charged. Either way, you become an ion. Okay? Either way, you become an ion. Nonmetals always have negative charges. Nonmetals always have negative charges. Metals always have positive charges. Okay? Metals always have positive charges. So please take out your periodic tables, ladies and gentlemen, because we are going to put some notes on it in just a few minutes that will help you remember this. So all of this reactivity, all of this stuff that we're talking about, ladies and gentlemen, comes down to how the electrons are arranged around the nucleus of an atom. And these circles that Declan has been describing, that is the way we drew them when you were in physical science. But what those circles represent is what is called energy levels. And when an energy level is filled, an atom becomes stable. The outermost level, at least. Okay? And always, 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 the inner levels get filled before you go to another level. So what that means is if there are electrons in the outermost level and it is not filled, the level below it is filled. Because the only way you would go to that higher level is because there's no more room at the lower levels. So the lower levels fill up. Then the outermost level is left with what's left over. Now again, maybe that's 1, 2, 3 electrons. Maybe that's 7, 6, 5 electrons. Okay? But you want to fill every energy level. And every energy level gets filled with 8 electrons. Except for one. The very first one. The very first one gets filled with how many electrons? 2. 2. Okay? The exception is the first level, it gets filled with 2 electrons. But it's easy to remember that exception because how many elements are in the first period of the periodic table? How many elements are in the first period of the periodic table? 2. Hydrogen and helium. That's it. Okay? 2 electrons fill that first level because there are only 2 elements in it. Okay? By the way, on the side of your periodic table, every period should be numbered. Those periods also represent these energy levels. So in other words, if an element is in the third period, like sodium here, that means that it has electrons in 3 different energy levels. If something is in the 5th period, like iodine, that means it has electrons in 5 different energy levels. Whatever period it is in determines how many energy levels it has. Okay? Now, all we're worried about is the last level. We don't care about the first 4. If it has 5 energy levels, we're concerned with how many electrons it has in the 5th. Is that level full? How close is it to being full? Okay? So, we always fill from the lowest levels to the highest levels. So there is no way you will have an electron in the 3rd energy level unless the first 2 are already filled. You will never have an electron in the 6th energy level unless the first 5 are filled. Okay? And each level represents a period on the periodic table, what we were just talking about. The first period represents the first energy level. The second period represents the second energy level. Questions? Okay. Before we go to there, ladies and gentlemen, take out your periodic tables. Let's do a little additions to them, ladies and gentlemen. Now, again, this is your choice on if you wish. Ladies and gentlemen, we're going to put a couple of notes on here for us. The first note we're going to put on there is under the word period. We are going to put energy level. Because periods also represent energy level, ladies and gentlemen. Periods also represent the energy level. Thank you, sir. Okay. Now, up at the top here, on the left-hand side, remember the bold zigzag line separates what from what? Metals from non-metals. So on this side of the periodic table are the metals. Okay. Metals have positive charge. Why?
Because they lose.
They lose electrons. They lose electrons. Metals always do this, ladies and gentlemen. Okay? Metals always lose electrons. They always have a positive charge. Therefore, we call them cations. Cations always have a positive charge, ladies and gentlemen. So then, over on the other side, we are going to put nonmetals. Now, if you need to, you should write yourself some note that maybe says, I probably should have added this here. Left of bold line. Meaning they're on the left-hand side of this bold line. Nonmetals are on the right of bold line. Okay? Nonmetals have a what kind of charge? Have a negative charge. Okay. Why do nonmetals have a negative charge? They gain electrons. They gain electrons. Which means, what is the name for a negative ion? An anion. That is the name for a nonmetal. Oh. All right. Now, the noble gases, and again, you can write this wherever you want on your periodic table. I'm putting it over there. group 18. Okay? They do not react, meaning they will not become a part of compounds. Do you want me to make that bigger for you? Okay? They are nonmetals, ladies and gentlemen. However, they do not react with any other element on the periodic table. Okay? They do not react with any other element on the periodic table. Choices, choices, choices.
Oh, for colors.
All right. Now I want to go back over to the other side to hydrogen.
Pretty much.
Hydrogen can act as a metal or a nonmetal, which means it can either be a +1 ion or it can be a -1 ion. Please understand though, it is actually a nonmetal. It is a nonmetal, but it can act like a metal does at times. Okay? It can act like a metal does at times. Questions? All right. Questions? All right. Okay. Now, there is a trend for electron arrangement, ladies and gentlemen, and it is based on the group or the family. Now, periods go across the periodic table. Groups go up and down. Okay? So we are going to talk about group number 1. That is this right here, ladies and gentlemen. That is group number 1. Okay? Now, technically, it also has a family name. The family name for group number 1 are called the alkali metals. Is this table filled in for you? No? Okay. All right. Everything in group number 1. By the way, hydrogen is not an alkali metal. Why? Because it's not a metal. However, hydrogen can act like an alkali metals at times. Alkali metals have one, what we call valence electron. One electron in their outermost shell. How many electrons fill the outermost shell? 8. So, alkali metals have 2 choices. They can gain 7 electrons to fill their outer shell. Or they can lose 1. Which one is easier? Losing 1. So metals, that first family, they will lose 1. They will have a +1 charge. Okay? And all of them will. Lithium, sodium, potassium, rubidium, cesium, francium. Every single member of that family will have a +1 charge. All of them. Okay? If we go to group number 2 on the periodic table, from beryllium down to radium, those are called the alkaline earth metals. Similar name, little different, alkaline earth metals. They now have 2 valence electrons. Okay? Which means they have 2 options as well. How many would they need to gain to become stable? They would need to gain 6 or lose 2, which is easier. That's why metals do what they do, ladies and gentlemen. That is why metals lose electrons. They have just a few in their valence shell, in their outermost shell, so they lose them. So they become a +2. Now, we're going to skip these elements in here. Groups 3 through 12 are called the transition elements. We will talk about them, but they do something a little different, a little bit unique. So we're going to skip them just for now, probably until tomorrow. Okay? So we're going to go over to group 13. Now, here's where scientists got real creative with names, ladies and gentlemen. Group 13 is the boron family. Named that way because boron is the top element in that family. Okay? Now, they have 3 valence electrons in this family. So again, they have 2 options. Gain 5 or lose 3. Which one is easier to do? It is much easier to lose the 3. Therefore, they become +3 ions. Okay? They become +3 ions. But please remember, for every rule in chemistry, there's always exceptions, and we will talk about some. Okay? Now we get to group 14. Again, real original name, carbon family. Now we have 4 valence electrons. So what are the 2 options? Which one's easier? They're both the same. You're absolutely correct. So in this family, ladies and gentlemen, you can become a +4 or a -4. Okay? Now we'll talk about which members do which in a little bit, but it's very predictable as to which will do which. Because metals always what? Metals always lose and non-metals always gain. Okay? So we've got metals and non-metals in the same family. The metals are going to behave the way they always do. The non-metals are going to behave the way they always do. Now we go over one more. We're into group 15. But now we have 5 valence electrons. So how many do you need to gain to become stable? 3, or you could lose 5. Well, which one becomes easier now? Becomes easier to gain 3. So now we have a switch. Instead of being positive numbers because we have been losing electrons, we're now going to start gaining them and we become a negative. Now, what will never gain electrons? Metals. Metals. Okay, we'll talk about that in a minute. Group 16 is the oxygen family. Okay? The oxygen family has 6 valence electrons, meaning it needs to gain 2 or lose, which is easier? Gaining the 2. Gaining the 2. So they become a -2. Group 17, now we go back, now we got a usual name. Halogens. Why? Because these were some of the first elements discovered along with the alkali metals and the alkaline earth metals. Okay? Anybody know what halogen means? It actually means salt former. These are the elements that, when they combine with the metals over here, make salts. So they are called salt formers. But they have 7 valence electrons, meaning they only need to gain how many? 1. So that's what they do. They gain 1. Now, we get to the noble gases. How many valence electrons do they have? They have 8. So why don't they gain any? They're already full. By the way, there is an exception to that. Which noble gas does not have 8 valence electrons? Helium. It only has, but it's still full. Just that first level only needs 2 electrons to be filled. Questions? All right. So let's go back, ladies and gentlemen, to our periodic table here. Let's go back to it. Now, we are going to start with the metals. And it is very important. You should put this underneath in the same location I am about to put this. So underneath francium, ladies and gentlemen, I am going to put a +1. Why? Why am I putting a +1 under francium? Everything in that family's charge is going to be +1. Underneath radium, I'm going to put +2. Underneath nihonium, element 113, I'm going to put +3. And underneath fluvium, I'm going to put a +4. But in the +4 family, we also have I'm going to put that at the top above carbon, -4. Why am I putting the -4 at the top and the +4 at the bottom, ladies and gentlemen? Non-metals are at the top, metals are at the bottom. Okay? Non-metals are at the top, metals are at the bottom. So what am I going to write above nitrogen? -3. What am I going to write above oxygen? Above fluorine? And above helium? 0. Okay? 0. Okay? Now, what this means, ladies and gentlemen, is that you can find the charge of almost any element on the periodic table. Just about any element on the periodic table. So, if we point to an element, gallium, what charge is gallium going to have, Evan? Nope. I'm sorry, I'm pointing to the wrong one. Gallium. Sorry, my bad. Gallium is a +3. Okay? Gallium is a metal. We go down to the bottom. Gallium will act as a +3. Okay? What will be the charge of strontium? Sr. Mason. It's going to be a +2. Okay? What about potassium, Isaiah? That's going to be a +1. Michaela, what would be the charge of nitrogen? -3. Okay? Rose, what would be the charge of phosphorus? -3. They're in the same group. They're going to have the same charge. Lucy, what's the charge on bromine? -1. Okay? -1. Declan, what's the charge on xenon? 0. It doesn't have one. It will not gain or lose electrons. Okay? Maya, what is the charge on chlorine? Charge on chlorine. Element number 17.
1.
Positive or minus?
Minus.
Yep. We got to be careful. Charges are always positive or negative and then a number. Okay? Positive or negative and then a number. All right, KP. What's the charge on boron?
-5.
Well, which one?
I don't know.
Okay, well, let me ask you this. Why do you think it's a -3? Well, first of all, why isn't it a +3? Let's go with that.
Because it's a non-metal, so
Good. It's a non-metal. It cannot be a positive charge. Good. So now, what do you think it is again?
-5.
That's perfect. Yes. It technically would be a -5 if anything. Why? Well, look at our pattern. -1, -2, -3, -4, -5. I'm not going to ask you about boron. I'm not going to. It's an exception. But if someone were to, on a game show, ask you what is the charge of boron for $1 million, you better say -5, and you better at least give me a share of it. Okay? Okay? So, in the same sense, what would be the charge on antimony? What would be the charge on antimony?
+5.
That would be a +5. Again, we're not going to put it down there. Why? Because we're not going to get to those. I don't think I give you many compounds with antimony in. But technically, it would be a +5. What would polonium be?
+6.
Technically, it would be a +6. Okay, technically it would be a +6. Now there are a couple of special elements that I do want to talk to before we get rid of this. Take this away for the day. All right, first of all, find the element zinc. Zinc is number 30 on the periodic table, ladies and gentlemen. In the box by zinc, please put a +2. Zinc is a very common metal used in a lot of compounds, and when you use it, it is a +2. Now, I realize we didn't tell you what the charges of those things were. We're going to talk about that tomorrow. But zinc is always a +2. The other one that we are going to do is silver. Ag, number 47. Silver is always a +1. Silver is always a +1, ladies and gentlemen. Okay? So, that's where we're going to stop for today. Questions? Now, here's what I will tell you, ladies and gentlemen. You need to bring your computers with you each day, and this periodic table with you as well. Why? This is the one that's going to be the important one for this unit, ladies and gentlemen. Okay? Questions?
Mr. Slaughter, are you ready to jump start?
I'm gonna go around the school, not everyone that got a baby.
Did Mr. Brink tell you about one?
I think I like split this on them. Declan, I have one mints and one pop rocks left.
I only have
I'm
100.
selling them to Josie Baby.
For $3.
Maybe we'll see how desperate she is. I'm just gonna get making them.
Have a great day, ladies and gentlemen.
I'm so sick of you.
For real, that supply and demand go crazy. Mr. Michelson would be so proud.
Even if there is no demand for him.